Hello, my dear student. I'm Saktwala from Educatiz. I will be with you in physics for Form 5. Today, my dear student, we are going to proceed with our discussion for our topic of the fluid dynamics, for our subtopic of concept of fluid motion. This is not a new term for you because since you was at Form 1, you tried to learn about the three states of the mass. And we said that this is categorized into three parts. We have the solid state, liquid state, and also the gas state. For our topic here, the solid, the liquid, and also the gases are found termed as the liquid. Kwa hizo tunaziita ni kama fluid. That is what we trying to explain here. Now, before we proceed with our discussion here, we were supposed to remember where we ended on the last session. On the last session, my dear student, we tried to see how can we state the principle, the law of mass continuity, or sometimes we say the principle conservation of mass. This is what we explained on the last session, my dear students. So welcome to proceed our discussion here. So on the principle of conservation of mass, we said that the rate of the mass entering at one point must be equal to the rate of mass leaving at the other point. This is what we explained on the last session. And we tried to demonstrate the formula of the mass of continuity. We say that the density 1 A1 V1 must be equals to the density 2 V2 and also A2. This A2 means the secondary cross-section area. But for incompressible fluid, we know that the density can't change, the density remain constant. We obtain that A1 V1 must be equal to A2 V2. And this explain about the volume flow rate, au tunaita the volume flux. This is what we explained on the last session. But for our today discussion here, let us see an example related with what we learned on the last session. So our example, as we try to see here, this is our example number 5.1, the first example on our topic number 5 here. So our example said that, my dear student, as we try to observe our example, say that water flows steadily at the rate of 100 centimeter cube per second. The water flow steadily. That we have the amount of water that flows through the tube. That the amount of water involve the rate of it means the volume, the rate of volume, the rate of flow, the rate flow of volume, which is equal to 1000 centimeter cube divided per second. This is what we have been given through a horizontal pipe of a non-uniform cross-section here. Now, that amount of water flowing at the steady flow, they are only the horizontal. They are flowing on the horizontal pipe. Now, imagine we have the pipe, and that pipe, my dear student, is placed horizontally. Ipo horizontal, labda pipe yetu tumeweka juu ya meza. Na ile pipe sasa ina contain a rate of flow of the volume. That is what we have been given here. So the cross-section here, this involves the cross-section, the non-uniform cross-section. But we have been required to find the volume of the water at a section where the radius of the pipe is 10 centimeter. Now, how can we find the volume? How can we find the velocity of water at a section where the radius we have given which is equal to 10 centimeter? Kwamba tuna amount of water water, tuna kiasi cha maji, na kile kiasi cha maji kina flow horizontally kwenye ile uniform cross section. It means tuna pipe yetu ambayo imeplaced horizontally. Sasa kiasi cha maji kina flow kutoka kwenye one ends kwenda kwenye other ends. This is what we have been given. So how can we get the volume, the velocity, my dear student? Here the key point that we are supposed to do is to summarize our given values. So on our question here, we have been given the rate flow of the volume. The rate flow of the volume, which is equal to 1000 centimeter cube per second. And also we have the radius of the pipe. The pipe contain the radius which is equal to 10 centimeter. So how can we solve these questions? From the equation of continuity, now let us recall the equation of continuity, which said that AV1, the volume and cross-section area that are found at one end of the pipe must be equals to the rate to the AV1 that are found on the other pipe. And we said that this is explaining about the volume flux, or sometimes we term as the rate of flow of volume. Kwa hiyo hapa ile formula yetu ile AV is equal, AV1 is equal to a 2V2 in explaining the rate of flow. Kwa sasa after there, my dear student, we should because our principle said that the AV remain constant for incompressible fluid. Kwa kama ina remain constant for incompressible fluid, now we can say that, my dear student, we could say that V over T, the rate of flow of a volume, must be equals to AV. It means rate of flow of volume. If we take this rate of flow of volume and express it in terms of cross-section area and the distance, we should get equals to AV. Kwa ni sasa na rate flow of volume. Now we have been given the rate of flow of volume, which is equal to 1000 centimeter cube per second, and also the cross-section area of the pipe must be equal to this one. We know that we get the cross-section area of the pipe by taking pi r square. Kwa tunapata ile kwa kuchukua pi r square. Kwa cross-section area must be equals to pi r square, where the r, we have been given the r, my dear student, which is equal to 10 centimeter. Now if we substitute for our formula of the cross-section area, which is equal to pi r square, we obtain that the cross-section area must be equal to 100 pi centimeter square, as we try to see here. Now after that one, my dear student, because our aim here is to find the velocity, the V. This is small v which represents the velocity. How can we get this V? We are supposed to divide it by A throughout. Now let us take A and divide it throughout. If we divide it by A throughout, we should obtain that the velocity must be equal to the rate of volume at the rate flow of volume. Then we times it by the reciprocal of the cross section area. But this is a V over 2 we have, which is equal to 1000 centimeter cube per second, where this cross section area we have tried to solve and obtain, which is equal to 100 pi centimeter square. Now if we substitute here, we could obtain that it means the place where there is this rate of flow of the volume, we are supposed to substitute equals to 1000 centimeter cube per second. Now as we try to see here. But in the place where there is this cross-section area, let us put its own value, which is equal to 100 pi centimeter cube. Now the thing that remain here is to simplify. We have 20 at the denominator here. Now let us cancel 20 at the denominator and also at the numerator. If we cancel here, we should obtain the velocity of the fluid, flow of the water flowing through the pipe must be equal to 3.18 centimeter per second. Now this will be the value of the velocity that we have been asked on our questions.